Peoples, we are looking at section 8.3, permutations and combinations. So here is a warm up for you just to kind of get started. We're trying to figure out with dealing with these different types of reactions. We have this different colors. We want to figure out how many different ways can we add the samples to the mixture. Okay, so we're mixing some samples and we have these four different vials or four different test tubes and we're mixing them. So we want to know how many ways can we mix them. So think about the order that we want to put them in, which one comes first, red, yellow, green, or blue, and how many different ways can you mix these together, these red, blue, green, and yellow colors. So think about that. All right, so let's go ahead and get into it. So we're looking at a thing called the fundamental counting principle. Now the fundamental counting principle is basically saying that when we're trying to figure out how many times stuff occur, that we can look at more than one event happening, so more than one thing happening, like the number of test tubes, right, adding into a mixture, then all we have to do is take how many ways that the first event can occur and times that by how many ways the second event can occur. So we take the number of times each event can occur and we multiply it. Okay, so here's an example. We got 4 entrees and 6 drinks. So how many different possible lunch combinations you can have? Well, there's 4 choices for entrees. So there's 4 different ways you can have those meals. Okay, and then there's 6 different drinks. So that's 6 different choices or 6 different ways you can rearrange those drinks. So 4 times 6 is 24. So there's 24 possible lunch specials that you can come up with. So that's how the fundamental counting principle comes about. You just multiply the number of ways you can do each thing. Okay, so let's go ahead and take a look at problem number 1. Problem number 1, here we have the lunch special kind of thing, but this time we have 3 choices. We have sandwiches, we have side items, we have drinks, and we want to figure out how many different lunch specials are possible. Okay, so I look at how many choices of sandwiches do I have, or how many possible ways of sandwiches do I have. So there's 1, 2, 3, 4, 5, 6 different ways here. And then I look at my side items. Well, how many choices for side items do I have? Or how many ways can I arrange my side items? 1, 2, 3, 4 different ways. And then my drinks. How many choices of drinks do I have? Or how many different ways can I rearrange my drinks? 5. And then I just use the fundamental counting principle and multiply all these together. So 6 times 5 is 30. 30 times 4 is just really 3 times 4 and add a 0, right? So 120 different lunch specials are possible. 120. So that's how you do it. Find out how many are in your first list, second list, third list, fourth list, how many lists you have, right? And just multiply those different ways together. And that is how many different combinations or how many different ways you can rearrange that. So here's your problem that you can do. So you're generating passwords that begin with a letter. So you have one letter followed by 2 digits. So that's numbers between 0 and 9. Numbers between 0 and 9. And a letter would be between A to Z, right, which is 26. Or A to Z if you're Canadian, which we do have one Canadian, right? So from A to Z. So there you go. So you multiply all these different ways that you can do, and that will be your total possible that you can run through. All right, so that is it for problem number 1.